All right, let's talk about something that seems super simple, but is actually a huge key to unlocking mathematical literacy. It all comes down to one tiny phrase, is, a. Sounds basic, right? But you'll see that understanding what this really means is fundamental to, well, thinking like a mathematician.
So, I want to kick things off with a question for you. A little riddle. Is a square a rectangle? Now seriously, pause for a second and think about it. What's your gut reaction? Better yet, ask someone else, a friend, a kid, and just listen to how they explain their answer. This one little question gets right to the heart of how math works.
So, what's the verdict? The answer is a big, unequivocal yes, and this diagram shows you exactly why. A square isn't just a square. It's actually wearing two hats at the same time. It's a rectangle because it has four right angles, and it's also a rhombus because it has four equal sides. You can see it right there in the middle, living happily in that overlapping zone of both categories.
Look, it all comes down to definitions. Think of it like a checklist. The rule for being a rectangle is you must be a four-sided shape with four right angles. Does a square meet that requirement? Yep, checks that box. Okay, what about a rhombus? The rule there is a four-sided shape with four equal sides. Does a square check that box? Yes, it does. A square follows both sets of rules, no problem.
So, the main takeaway here is a square absolutely is a rectangle. But here's the cool part. The chain doesn't stop there. Because it's a rectangle and a rhombus, that means it's also a parallelogram. And guess what? A parallelogram is a quadrilateral, which is a polygon, which is a shape. It's this whole family tree, this chain of identity, and every single link is locked in place by a precise definition. Now you might be thinking, okay, I get it for shapes. But this is a relationship, isn't just some weird quirk of geometry. It's a fundamental pattern you see all across mathematics. Let's switch gears for a minute and look at numbers. Let's take the number 7. Its value is always, well, 7. But just like our friend the square, it can belong to a bunch of different clubs at the same time. This picture shows it perfectly. There's the number 7, sitting inside all these bigger and bigger mathematical universes, all without changing what it is.
So let's trace its journey, right? 7 is a natural number, the kind you count with. It's also an integer. It also is a rational number. And you might ask why? Well, because you can write it as a fraction, 7 over 1. Simple as that. It also is a real number, and believe it or not, it's even a complex number because you can just write it as 7 plus 0i. Its value never changes, but it qualifies for membership in all these different sets.
Here is another fantastic example, this time with triangles. Every single equilateral triangle is also an isosceles triangle, but and this is important, notice the direction of that arrow. It's a one-way street. Not every isosceles triangle is equilateral. That direction is absolutely crucial in the language of math. And here's the simple reason why that one-way logic works. The official definition of an isosceles triangle is that it has at least two equal sides. An equilateral triangle has three equal sides. So does having three equal sides satisfy the condition of having at least two? Of course it does. So it gets to join the club. It qualifies. We can even take this whole idea into 3 dimensions. A cube is a rectangular prism, which is a prism, which is a polyhedron, which is just a fancy word for any 3D shape with flat faces. You can see it here as a chain of inheritance. Each thing on the left satisfies all the rules of the category to its right. Let's just walk that path for a second. A cube is a rectangular prism. A rectangular prism is a prism. A prism is a polyhedron. And a polyhedron is a 3D shape. It's just this beautiful logical flow. And what that means is that any property that's true for all polyhedrons has to be true for a cube too. Okay, so we've seen this pattern with shapes, with numbers, even in 3D. But why are we focusing so much on this little phrase, is a? Because understanding its specific grammatical power is what separates just knowing some math words from actually speaking the language of math. The source material we're drawing from puts this perfectly. In everyday conversation, we can be a little loose with our language. But in math, when you say something is a something else, you're not just making a casual comparison. You are making a powerful, precise statement with real logical consequences. So let's break down that strong meaning. When we say A is a B, we're really saying 3 different things all at once. First, classification. A perfectly fits the definition of B like a key in a lock. Second, inclusion. The whole group of things called A fits neatly inside the bigger group of things called B. And third, inheritance. This is the big one. Every property that B has, A automatically gets. It inherits all those traits.
When you really master this concept, you're learning some core mathematical skills. It trains you to read definitions with incredible care. It makes you understand that logic flows in a specific direction. It gives you a shortcut for applying properties. And most importantly, it gives you the power to communicate your thinking clearly and justify your reasoning by saying, this is true because of this definition.
You know, in the end, it all comes back to one big idea. Math is a language. And like any language, it has its own grammar, its own logic, its own rules. The true meaning of a word like square isn't just in the shape itself. It's in the web of connections it has with rectangle and rhombus and all the others. Understanding that grammar is the real key to fluency.
So I want to leave you with this thought. We've seen how this is a grammar works in math, but where else is it hiding in plain sight? Think about biology, right? A poodle is a dog, which is a mammal. Think about music. A viola is a string instrument. What else in your world is defined by this surprisingly powerful relationship?